Have you ever heard of a rogue DHCP server? A rogue DHCP server basically means a DHCP server that does not supposed to be connected to your network. It can be happening intentionally by a hacker or unintentionally by a user. In either cases, the outcome is not what we want. So because it brings chaos or man-in-the-middle attacks. Stay with me until the end of this video and I'll show you how you can leveraging DHCP snooping to prevent these rogue DHCP servers to your network. If you remember from the previous videos, when we spoke about the DHCP process, we said that when a computer wants to ask for a DHCP address or ask for an IP address from a DHCP server, the overall process is called DORA, or 4 steps actually happening: DHCP discover, DHCP offer, DHCP request, and DHCP acknowledge. And from these 4, 2 of them are sourcing from our DHCP client, which is DHCP discover and DHCP request. And also 2 of them coming from the DHCP server, which is DHCP offer and also DHCP acknowledge. When you enable DHCP snooping, your switch actually monitors all DHCP messages. And if anything, DHCP discover or DHCP request comes through, it doesn't care about it. But if someone wants to respond to those DHCP discovers or requests through offers and acknowledges, then it comes to the picture and prevents those, unless you define that specific port that is connected to your DHCP server or your upstream switch or router that is going to relay your DHCP messages as a trust interface. Otherwise, it will not allow any offer or acknowledge going through the network. So if someone connects a rogue DHCP server here, and when a PC, for example, this one sends a DHCP request or DHCP discover here, and this rogue DHCP server wants to respond to that, switch will not allow this response. So basically, this will not allow that rogue DHCP server to assign any IP address to your computers or any DHCP client you have in your network. Let's kick off the procedure without having DHCP snooping enabled. If in this PC I run this command IP DHCP, you can see that this DORA procedure happens. And finally, my computer receives this IP address from the DHCP server with this gateway settings. Based on this configuration, at the moment, any DHCP server connected to any interface on this switch can respond to these DHCP discoveries. This is not what we want. So what we are going to do is we are going to enable DHCP snooping in our switch. To enable DHCP snooping in your switch, we have to run 2 commands. First one is enabling this feature on your switch, and the next one tells your switch in which VLAN you want to have DHCP snooping enabled. So first we say IP DHCP snooping. This will enable this feature on your switch. And then, since this is a default switch configuration and all interfaces are in VLAN 1, I'd say IP DHCP snooping and then VLAN 1. So I enable DHCP snooping in VLAN 1. Now, if I run show IP DHCP snooping, you can see that DHCP snooping is enabled. This one. DHCP snooping is enabled, but there is no any interface as a trust interface because all interfaces by default will be untrusted. And also option 82 on untrusted port is not allowed. This option 82 is useful when you have DHCP relay configuration in your network, because this option 2 allows devices to add extra information where this DHCP request came through, so the DHCP server can respond back if it is not in the same network. If your switch is not a DHCP relay, and like this scenario, you have your DHCP server connected directly to your switch, and for whatever reason this switch is not your DHCP relay server, then you have to disable this option. Otherwise, some DHCP servers will not respond to these DHCP messages that have option 82 enabled with this situation. Some may not. So it's better to disable this option. I show this in action. Okay, so now if I run IP DHCP again, now DHCP snooping is enabled and there is no any DHCP trusted interface on the switch. So you can see that I continuously send DHCP discovers and nothing comes back because we don't have any trusted trusted interface. To allow a specific interface that is like this scenario is connected to the DHCP server, or it is connected to another switch, another router, etc., and it's an uplink, whatever, it's a trust interface that allows DHCP messages to go through. So in this scenario, I'd say interface gigabit 0/0, and then I say IP DHCP snooping, and then trust. This makes interface gigabit 00 a trusted interface. So if I run show IP DHCP snooping again, you can see that this interface is now listed as a trusted interface, and also allow option 82. Okay, so I allowed gigabit 00, and if I go here and capture my packets on this interface and bring my VPC here again, and also my captures, and if I capture DHCP messages, you can see that the messages coming through that interface gig, now our switch allows it, and you can see that the DHCP discovers receives on this DHCP server, but this doesn't reply to that. Why? Because of that option 82. So if your switch is not the DHCP relay agent for that VLAN, you have to disable this option 82. So we go to global configuration mode and we say IP DHCP snooping, and then information, and then option, and I forgot a no in the beginning. So this will tells the switch to disable adding that option 82 to the messages. So if I go back to show IP DHCP snooping, you can see that now insertion of option 82 is disabled. Now if I run my DHCP requests again, you can see that this time everything will come true. And if I go back to my packet capture here, you can see that the initial messages had this DHCP option 82 configured in them, but the next ones that I disabled 82, they do not have that option 82 enabled on them. So now my DHCP server will respond. And as I mentioned before, this depends on the DHCP server. Some DHCP servers respond to these type of messages, but some don't. But Cisco recommends you, if your switch is not a relay server for that message, for that VLAN or that DHCP procedure, just disable this option 82 on your switch. When we enable DHCP snooping on our switches, having DHCP enabled and having those type of investigations and allowing traffic or disallowing traffic, etc., requires some CPU cycles. And this prone our switch to an attack that is called denial of service. In this attack, hackers can bombard your switch with DHCP messages, And then processing these huge amount of DHCP messages will increase the CPU usage, and then eventually your switch will not be able to do its normal job because it does handling all of these DHCP requests. So DHCP, like a CPU usage, gonna be turning to 100%. So switch will not be able to do other packet processing, and no one would be able to connect to the rest of the network via this switch. So to prevent these type of attacks, when you have DHCP snooping enabled, we can implement rate limiting. And this rate limiting is only happening on DHCP packets, not on all packets. So, for example, on the interfaces that are connected to endpoints, we say number of allowed DHCP packets per second is like 10 or 5 whatsoever. And on the interfaces that are connected to upstream switches or DHCP servers, etc., for example, it can be 100, whatever, depends on the number of devices you have in your network. You have to benchmark what is the best number for your network. Anyway, we can do this rate limiting to avoid these type of attacks. To apply this rate limiting, we have to go to interface configuration mode. For example, we go to our interface gig 00, which is connected to our DHCP server, and we say IP DHCP snooping, and then the command is limit and then rate, and then you can specify how many packets per second you want to allow on this specific interface. And for example, you say 100. And you have to do it on all interfaces. This is a separate setting that you have to do per interface and per requirement. When we configure rate limiting and that rate limiting breaches on an interface, that is a security violation. So what our switch will be doing is putting that interface into error disabled mode. And if you remember from the port security video, we mentioned that when your interface goes to error disabled mode, you have to manually shut them down and bring them back up via no shutdown. This will happen for rate limiting of DHCP snooping as well. But for whatever reason, you don't want to go through that manual procedure and you want to make your switch to allow that interface to be enabled again automatically if a DHCP snooping rate limiting breach happens, then you can configure this via error disable recovery feature. So we go to global configuration mode and we say error disable and then recovery, and then we say cause. If the cause of error disable is DHCP rate limit, then what you do is error disable recovery interval, and then you mention how many seconds. For example, after 120 seconds. So with this configuration, if any DHCP rate limit violation happens, switch will automatically recover that interface after 120 seconds. But it's up to you. If you want to configure this. There is a security risk for this because it will bring the interface back up, and if there is a hacker connected to your network, then they will try again, and this procedure will continue. Anyway, they will not be allowed to do that, but they can try it again. One good thing about DHCP snooping, other than providing security feature and avoiding rogue DHCP in our network, is it is creating a table of IP addresses and MAC addresses of the devices that got their IP addresses from the DHCP server. And that will be useful in other security features like dynamic ARP inspection that we will be talking about it in the next video. So if I run show IP DHCP snooping binding, you can see that this table is showing you this MAC address is binded to this IP address. This was the lead time, it was a DHCP snooping, and this is the interface that is connected to. So this information can help us to implement and use it in other security features like dynamic ARP inspection, which I will be showing you in the next video. But the thing is, this information is actually happening or collecting through dynamic procedure. Whenever a request coming through and the response coming through, then the switch will put this in the table, and this table saves in the RAM. So whenever your device reboots, this table will be gone as well, and you have to repopulate it through this dynamic procedure. But in some situations, you may need to have this database consistent and save it somewhere. So if you need that, which is happening in the DHCP snooping database, but if now I run show IP DHCP snooping database, you can see that we have nothing here because we haven't configured it, and this is not configured by default. So if you need to keep this information somewhere, so whenever your device reboots, it doesn't have to repopulate those information via dynamic procedure and you save it somewhere, you have to go to global configuration mode and say IP DHCP snooping, and then database, and then mention where you want to have it. You want to have it on your device in any of your flash memories, or you want to copy it to an FTP server, HTTP server, HTTPS server, RCP, SCP, TFTP, all of these remote locations, you can have your database there too. But for example, I say I want to have it on my flash and I want to give it a name like DHCP snooping database. Okay, so now if I go to show IP DHCP snooping database, you can see that there is some information here. Successful transfer, successful writes, total attempts, so something happened here. And so if I go to dir flash 0, you can see that there should be a file here, and you can see this file here, and this file will remain in this location because flash is not a volatile memory. So if your device reboots, this information will remain on your switch. Alright guys, this was our today's video. We covered exam topic 5.7, the DHCP snooping part. I know I promised you to cover dynamic ARP inspection in this video as well, but to keep the video as short as possible, I omitted it for this video and I will be talking about it in the next video. I wish you enjoyed today's video and see you in the next ones.